Look at this coelacanth, it's so ancient, it looks like it belongs to a different time. It's almost like a living fossil. Living fossil, we hear that term a lot, but what does it mean? It sounds like a night at the museum situation, but it's actually a term used to describe a living organism that looks pretty much the same as its ancestors way back in the fossil record. So our coelacanth friend is a living fossil because not only do we have living specimens, we got old bones. The phrase living fossil is itself a bit of a fossil. Darwin invented it not to be used as a scientific term, but more as a poetic descriptor. A lot of scientists don't like it because when you call an organism a living fossil, it implies that it hasn't evolved. So it's important to note that while the living specimen and the fossil specimen look the same, they're not the same species. If we compared their genomes, they'd be different because of the gradual changes that occur in a genome over many generations, called genetic drift. Now, living fossils are pretty special, but there's a more specialer version of them. Sometimes living fossils haven't just been around a long time, they're also the last remainders of what was once a widespread or diverse group. For example, saiga antelopes were all over the place in the last ice age, but now their range has restricted from this to this. Sometimes it's more of a Highlander thing where a group was historically diverse with all kinds of species and then natural selection was like there can be only one and then they all died out leaving one member. The bear subfamily Tremarctinae, the short-faced bears, are an example of this. Yep, a lot of big bears in the Ice Age. Today, only one member of their group remains in the forests of South America, the spectacled bear. When evolution goes all Marie Kondo on a group like this, we call the last man standing a relict species or relict taxa. My favourite relict species are hoatzins. Hoatzins used to be spread across Africa and Europe, and there were a bunch of different species. Their range started to shrink, presumably as arboreal predators spread, climbing up trees and gobbling up the slow hoatzins. And there are none left in Europe and Africa today. Wait, so doesn't that just make them extinct? Nope, at some point they somehow got to South America. There are a few theories on how they did this. The raft theory is pretty fun. It posits that they floated across the ocean on debris. But they weren't satisfied with being a relic. No, they were like, we're going to evolve traits that make us even more relic-y. So they re-evolved the front limb claws that most avian dinosaurs had lost, which they use as babies to clamber around in the trees and then lose again as adults. So you see, a somewhat common trend with relic species is that their persistence has a bit to do with where they are, and how that environment shelters them from the forces that drove the rest of their kind to extinction. Or they have adaptations and traits that the rest of their kind didn't that allowed them to survive. So they might live in a place where human activity was limited, or where predators, competitors or otherwise invasive species couldn't reach them to be a pain, or in a spot that was sheltered enough to protect them from changing climatic conditions. Across Africa, Europe and Asia, there was a genus comprised of many species that was incredibly successful. They were apex predators that left all kinds of evidence of their existence, even shaping the land around them. Despite their success, something went wrong and one by one, members of this genus vanished. Today, there's only one left. Us. Homo sapiens are a relict species of the once diverse genus Homo. In fact, at one time on Earth, we shared the planet with Neanderthals, hobbits, Homo erectus, and a mysterious group of humans called Denisovans, of which we only have a few bone fragments. So why is it important to understand relic species? Well, for one thing, it's cool, but they're also a look into the past and they give us information on the processes of diversification and extinction. This helps us preserve them and other species by providing a kind of species library. For example, if we want to know what species might do well in a warming climate, we can look at relics of a time when the climate was warmer and identify what traits they had that suited them to that. We also need to understand them to protect them. A lot of relics are endemic to their location, meaning it's the only place they're found. If you only exist in one restricted area, any changes to that area can mess up your population pretty bad and put you at risk of extinction. They got no backups elsewhere. Humans are endemic to planet Earth, so we should probably make sure nothing happens to our big ol' habitat. I mean, we don't want to end up like these guys.